Hi everyone, and welcome back to our IGCSE Computer Science lecture series. Today, we're going to look at how to convert directly between hexadecimal and binary. In the last video, we learned what hexadecimal is and why it is used, and now we need to be able to move between the two number systems quickly. Now, here is the key insight that makes this simple. Now, one single hex digit always corresponds to exactly 4 binary digits. So for example, here we have F in hex, which is represented by 1111 in binary. We have A, which is represented by this number in binary, and we have 3, which maps directly to 0011 in binary. Now, for 4 binary digits are called a nibble, and every nibble maps to exactly 1 hex digit. This means converting between hex and binary does not require any arithmetic at all. You just swap each hex digit for its 4-bit equivalent, or group the binary into 4s and swap each group for the hex digit. Now, let me show you an example from hex to binary. Now we have the following table, which we can use as a reference. So, as we said, we replace each hex digit with its 4-bit binary equivalent. For example, we have 0 mapping to this, we have A mapping to 1010, we have F mapping to 1111. And the method is simply to replace each hex digit with its 4-bit binary equivalent. Well, I would strongly suggest that you learn this table by heart as it's quite useful and it comes up constantly. Now let's check an example to make this more simple. Let's say we're converting the number B7 to binary. What we do is we check every digit, every hex digit, and we check its binary representation from the table. So for example, here we have B. What does B map to? Well, it maps to 1011. So we write that down. And we check 7. Well, that is 0111. And in the end, B7 in binary is this number. Let's check this other example. We have 3A. What do? We check the table. 3 maps to this number, and A maps to this number. That's easy. You write this down. Now that was hex to binary, which seems quite simple and quite intuitive. Let's now check how binary to hex works. So as we said before, the algorithm for this is that we split the binary number into groups of 4, and we always start from the right. We convert each group of 4 to its hex digit. Remember that we said that every hex digit can be represented by 4 binary numbers. And we write the hex digits in order. Now this is the algorithm that we use to convert a binary number to hex. But let's see how this works in practice. Let's say we have the following example. We need to convert this binary number to hex. Let's follow the algorithm. First, we split the binary number into groups of 4, and we start from the right. This is very important. Starting from the right here, let's group it into groups of 4. This would be 1, 2, 3, 4. That's one group, and we have it here. And then another group, 1, 2, 3, 4. Here it is, and we group it here. Now we look at the table. What does this number represent? It's 1101. So it's 1101. Well, that maps to D in hex. It's great. We write that down. And then we have this number, which maps to 6 in hex. And lastly, we have this number in binary, which is the equivalent of D6 in hex. Seems simple. Now let's see another example. This might look a bit trickier. Now, why is that? First of all, so far we've been dealing with only 8 bits as an example. And when we have to convert into groups of 4, well, 8 is divisible by 4, so obviously you would know that there would only be 2 groups. But what happens when you have 10 digits, 10 binary digits? How do you group them into 4? Well, the key here is to pad. You always pad the number with leading zeros, and you pad them on the left here, so that you create the number of digits to be divisible by 4. So if here there are 10 digits, you add 2 zeros on the left side, which makes the number of digits into 12. And what happens? 12 is divisible by 4, so that leads into 3 groups of 4. And then that's simple. You just follow the algorithm. You start from the right. So it's 1, 2, 3, 4. You have one group here. And then again, another group here, and another group here. Once you have the numbers separated like that, you just look at the table referenced above, and then you map them to the corresponding hex values. And that's simple. Remember, always pad with leading zeros on the left to complete groups of 4. This is very important. Now for key takeaways for this video. Remember that one hex digit is always grouped into 4 binary digits, or as we call it, a nibble. To convert from hex to binary, we swap each hex digit for its 4-bit binary equivalent. Remember this table that we showed at the beginning? It is very useful to learn this by heart, as it will come very, very often into problems. And the next one is, in order to convert from binary to hex, remember we group into 4 groups of 4, and we start from the right, and then we swap each group for its hex representation. A key point to remember is that if the binary doesn't split into clean groups of 4, meaning if the binary number has a number of digits that is not divisible by 4, then we pad with zeros on the left. We never do it on the right. This one is very important. Coming up in the next video, we will have denary to hex. We will cover the conversion between denary to hex and hex to denary. So see you there.